And good morning, good afternoon, and good evening, wherever you are. Welcome to this first Art Ratio webinar on the subject of how light exposure affects your art collection. I am your host. My name is Manoj Patak. I'm a chartered engineer with a background in physics and a founder and CEO of Art Ratio, and we're display case manufacturers using smart glass to protect fragile and rare art collections. A quick shout out to all of the people who are connecting to this webinar from different parts of the world. I see messages coming in from Canada, from the UK, and also from other places such as Hong Kong. So welcome everybody. Our partners include the Museums Association, where we are corporate members, LAPADA, where we are approved service providers, the Institute of Conservation, otherwise known as ICON in the UK, and CIHA, who provide doctoral training in the area of arts and heritage. They are backed by UCL, London, Oxford, and Brighton. So who is this webinar for? It's primarily for collectors, whether you are private or corporate or institutional. It's also aimed at the art trade, which includes auction houses, dealers, and galleries. It's also aimed at architects and interior designers, and for ancillary services such as insurers and also consultants and art advisories. So let's get straight into it and look at the first question, which is, where is art typically exhibited? So we are all used to going to museums and galleries, of course, but we often forget that there are large amounts of art collections which are exhibited in private residences, for example, in corporate offices. This is where the private collector and the corporate collector comes in, as well as in art fairs and in auction houses, whether they're having a public auction or it could be a private sale. We can also find art exhibited at in hotel lobbies and in corporate events for the banking sector, for example, which is very popular, as well as in a recent trend to display art in airports and even in super yachts. So what do all of these places have in common? And that comes down to abundant daylighting. Now, with the exception of museums, which tend to be very controlled environments, all of the other examples that I give here have abundant daylighting, as well as climate controls, which are optimized for humans and not art necessarily. There are also other risks, such as vibration and pollution and accidents and theft, of course. So why display art? Well, apart from the obvious question of wanting to enjoy the beauty of art, or perhaps learning or enjoyment, there also comes the issue of exposure and value. So Dr. Sarah Thornton, who's the author of the book 7 Days in the Art World, claims that collections are more likely to increase in value if they are seen by the general public, because art accrues value through exposure. And she claims that this is particularly important for contemporary art. The other quote which I wanted to share with you comes from Orlando Rock, chairman of Christie's, who says that the condition of a piece can be crucial in determining its value. So we have two pieces of information here: a connection between value and exposure or exhibition, and the connection between value and condition. So what we've done is to put this into a graph. And on the horizontal axis, you can see exhibition. In other words, how much exposure the object is getting, and we control that, of course. On the y-axis, we can see value. That could be interpreted as the market value, in other words, economic value. It could be cultural value. It could be sentimental value. And if Dr. Sarah Thornton is right, and all her peers agree with her, then the initial part of the graph, as exhibition increases, we should see an increase in value. On the third part of the graph, as exhibition continues unrestricted, we can fall down to the simple rules of physics and chemistry, which is where the greater the exhibition, the greater the light exposure, the more damage will be done to the object, the condition will fall, and quite possibly then as a result of that, if Mr. Orlando Rock is correct, then the value will also fall. So if the first part of the graph is going up and the third part of the graph is coming down, there must be a peak somewhere. We think there must be a maximum value for which you can exhibit. In other words, an optimal amount of exhibition time, which would maximize the value of your art collection. Now, we at Art Ratio call this the balance point between exhibition and conservation. We don't know really what the graph actually looks like, if it looks like this or it looks like this, but we are surmising that there must be a peak somewhere, a balance point or an optimal point. So which type of art materials are most sensitive to light? Well, we can turn to the British Standards Institute document, BSI PAS 198, and that talks about 4 types of materials: silk, nylon, works on paper, and color photographs, which are all highly sensitive to light. Now, to answer one of the questions which I posted on LinkedIn, which of these types of materials is not sensitive to light? Well, we have to delve a bit into the works on paper, because you can have works on paper based on wood pulp and those based on rag paper. And curiously enough, those based on rag paper or cotton paper are not sensitive to light. That is according to the British Standards Institute document BSI PAS 198, which is quoted below. But so far, we've only talked about the substrate material. What about the dyes and the pigments? So dyes used for tinting paper in the 20th century are all very sensitive to light, as are insect-based extracts, just carmine. They're all very sensitive to light, as are most early synthetic colors, for example, anilines. So how serious is this issue? Well, if you look at the typical light levels that you would expect to find in, for example, a museum, which might be from 50 lux up to 200 lux, depending on where you are in the galleries. If we take an average value of 100 lux and you were to exhibit some of the most sensitive materials we just looked at, so silk or nylon, wood pulp-based paper, then you would expect to see a noticeable fade in anything from 7 months upwards, and an almost total fade in anything from 15 years upwards. So we at Art Ratio are not too worried about the museums, because they know what they're doing and they're very controlled environments. What we're most concerned with are the private collections and the corporate collections and the retail collections, which tend to get exposed to excessive amounts of light. So if you look at a typical private residence or an office, then you can expect to find something like 500 lux, 5 times the amount what you would find in a museum. And if you were to exhibit any of the fragile materials we just looked at in the previous slide, you can expect to see a noticeable fade in anything from 7 weeks upwards, an almost total fade in anything from 5 years upwards. So if you are a collector and also an investor in art, I'm sure that you are not wanting to see a deterioration in the condition of your investment and therefore the value of your investment from anything like 5 years plus. If we look at the retail environment, so now we're talking about dealers and galleries as well as luxury retailers, those exhibiting, let's say, silk or textiles, leather, for example, you can expect to find something like 800, 900, or 1,000 lux in those types of environments. And if you exhibit the fragile materials in 1,000 lux, you can expect to see noticeable fade in anything from 7 days upwards. And you can expect to see almost total fade in anything from 6 months upwards. So from the Art Basel report 2019, we know that dealers have about 75% of the stock in dealers and galleries takes more than 6 months to sell, which means that it's quite possible that any of those fragile materials are actually decaying whilst they are on display for sale purposes. So clearly, the business case is very clear here in this case. The biggest need really comes from private, corporate, and retail collections. So what is light? Well, here you see an image of the sun and the different levels of wave bands, such as ultraviolet on the left-hand side, visible in the middle, and infrared on the right. To the left of this diagram, which is not shown, are all of the gamma rays and the X-rays, but they are all cut out, of course, by the Earth's upper atmosphere. The same goes for UVC and parts of UVB, which are also cut out by the Earth's upper atmosphere. Ultraviolet A, however, is not, and it gets straight through to Earth, and it can go straight through float glass. So we do need to worry about UVA. We intend to have a webinar on the subject of ultraviolet light. If you're interested in seeing such a webinar, please put a message in the chat and vote it up. On the right-hand side, you see infrared. We're going to talk a little bit more about infrared right now. So there is a domino effect. With the sunlight that's coming down to Earth, about 50% of that is infrared. The highest frequency part of that is called near infrared, and it's not blocked by float glass. That's typically the type of glass that you would have in your window. And so it causes heating. If you put your hand out in the sun, what you're feeling on your hand, that sensation of warmth, that is near infrared. It causes a rise in temperature. And for every 5 degrees C rise that it might produce on your artworks, you can expect to see a doubling in the reaction rates of organic materials. And that results in desiccation or drying out. Now, because there is an inverse relationship between temperature and humidity, as the temperature goes up, the humidity or relative humidity comes down. So for every 2 degrees C rise, you can expect a reduction of about 6% in the relative humidity on the item's surface, leading to the movement of moisture, and that can result in flaking and delamination. Now, most people stop there. They talk about light, temperature, and humidity. We go a couple of steps further. So imagine for a second that the relative humidity has dropped. You can imagine that there's less moisture in the air. And we know that water is electrically conductive, which means that there's less water in the air, which means that the air is also reducing in electrical conductivity. A reduced relative humidity reduces the electrical conductivity of air. And so if you have any insulative surface like glass or acrylic, and simply by rubbing some textile across it, you can transfer electrostatic charge to that insulative surface. Now, normally that charge would dissipate away thanks to the moisture in the air. But if you reduce the relative humidity, that charge cannot then dissipate away to electrical earth. And what happens to it? It accumulates. And it accumulates up to the point where, in the extreme case, you could get a spark. It's very unlikely, thankfully enough. But what's more likely to happen is that you will get a buildup of the electric field, and that can attract away friable media such as graphite and chalk and pastels. So those are media that you can find. Basically, your work of art is going to be deteriorated directly by the electric field. So you have a very close distance between the glass and the artwork. That's one thing you need to work on. That's why they have anti-static coatings. So you might think that's not very common. In fact, we took part in a project a few years ago where that actually turned up as an issue identified by the museum conservation staff. I'll talk about that project in just a minute. Just to finish off this slide, if you have reduced relative humidity, that also facilitates the transfer of dust by electrostatic forces within the display case or within the room. And that reduces the air quality also. So there's a fascinating domino effect, and it all starts with sunlight, and it moves on to impacting the temperature, the humidity, the static electricity, and the air pollution. And all of that is documented in BSI PAS 198. So what solutions are available? Well, in the extreme case, you can just go for permanent storage, climate controlled perhaps. You could go for curtains on the windows, or blinds or shutters. They could be manual or motorized. In the example you see on the left-hand side, it's a manual shutter, which is placed directly on the display case. Of course, it relies on user compliance to actually make sure that the people who lift up the shutter then actually pull it back down again. Otherwise, the work suffers some light damage. Some museums have object rotation schemes in place and also passive filters. These are either coatings or films, sometimes adhesive, which can be put onto light fittings or onto the window facade itself. They don't change their behavior. Whereas active filters do change their behavior. And these are normally films which can be adhesively placed on the outside of a window surface, or often they're laminated inside the glass. That can be placed on display cases, for example, or on the window facade. So some examples of active filters include electrochromic glass, SPD glass, that's the type of glass we use in our display cases, PDLC glass, APD glass, photochromic glass, thermochromic glass, etc. There's quite a few technologies out there. If you're interested in knowing more, we are planning to do another webinar just on active filters for art collections. If you'd like us to do that, please give it an upvote and tell us in the chat on the right-hand side. So how does art ratio solve this problem of light exposure? Well, if you look at an existing vitrine that you find in any museum or any collection, you have 100 lux shining down through normal glass, which might have, let's say, 95% transmittance, so 95 lux will get through. If you multiply that by the 3,000 hours that the exhibition is open per year, then you get 95 times 3,000, which is 285,000 lux hours of exposure in a year. If you're talking about exhibiting some of the fragile materials that we looked at before, then they will typically have a maximum exposure limit of 15,000 lux hours in a year, which means that the example on the left is exceeding the light exposure by almost 20 times. Our solution, which appears on the right-hand side, that's the art ratio vitrine, has the same amount of lux coming down, 100 lux, but this time we're using electro-optic glass, or the active filter glass I mentioned before, which has a variable transmittance from 0 up to about 50%, which means that either 0 lux gets through, in other words, it's opaque, or a maximum of 50 lux would get through in this particular example. So in other words, half of what's coming from the light source, 50 lux. And if you multiply 50 lux by, let's say, 300 hours per year, which is the time that we're restricting or the object is actually being viewed, so that would correspond to a 10% popularity. So instead of 3,000 hours, how many people are actually seeing the object? Let's say about 10% of that time. So that would be 300 hours. Multiply by 50 lux, that would give you 15,000 lux hours per year, which is within the recommended maximum exposure limits for those types of materials. So art ratio vitrines allow you to tune the amount of exposure according to the light sensitivity of the objects inside the vitrine. Here's the project which I mentioned before. This is a project that we did at the Royal Engineers Museum in the UK. The object that you can see in the frame on the left-hand side is the original map of the 1815 Battle of Waterloo. And when the museum contacted us, they specified two main requirements. One, of course, was that this object is very light sensitive. And secondly, this document still has the original graphite pencil markings of the first Duke of Wellington. That map was used in the actual battle. And apparently it still has the blood of one of the soldiers who was killed in the battle. So it's a fascinating document, historically, of course, very important. And we have a blog article, which is highlighted just below in the URL, which explains a bit more about what we did to try and reduce the lift-off of the graphite pencil markings, as well as reducing the light exposure damage on this important object. So as a final slide, once again, we're boutique manufacturers of smart glass display cases and frames and tables and smart plinths. We've had the great pleasure over the past 10 years to protect some very important, very iconic objects. Here's some examples given here. 15th century books of ours at the Swedish National Museum. Original books by Sir Isaac Newton for a private collector in London. The Battle of Waterloo map, of course, as I mentioned, but also another post-battle Waterloo map for a private collector in London. And then an original Torres guitar from 1888 at the Spanish Guitar Museum. So we have finished the webinar. I would like to ask you if you have any questions, please fire away. And if you have any questions, please put them in the chat now. I'll wait for a couple of minutes. And I don't see any questions, but I want to thank you all for your time. And we'll be having more webinars in the future, focused on particular topics. This will remain open. A question coming from Pandora, and she asks, can you switch off the smart glass remotely? Yes, that is possible. It's connected to the internet, or rather to your own intranet. So we can find ways to switch it off from a number of different locations. Of course, we try to do this securely so that other people can't do the same. Okay, so thank you very much for your time, and I wish you a very good day, and I hope to see you on another Art Ratio webinar in the near future. Thank you very much.